Roof ventilation and insulation work together to solve 4 critical problems: condensation control, temperature control, energy efficiency, and ice dam prevention. Understanding how these systems interact is essential for evaluating complete building performance, not just individual components. Attic ventilation prevents moisture vapor accumulation in roof spaces and helps dry low levels of condensation that form on the underside of the roof decking. Without proper ventilation, trapped moisture creates ideal conditions for mold growth, wood rot, and insulation degradation. And the key is continuous air movement that carries moisture-laden air out of the attic space before problems develop. Ventilation reduces roof deck temperature during really hot weather, which improves shingle durability and extends roof life. Cooler attics also mean lower cooling costs because less heat transfers into the living spaces. And this is why proper attic insulation and ventilation work as a team. The insulation keeps conditioned air inside, while ventilation prevents overheating in unconditioned spaces. Ice dams form through a predictable 5-step process. Poor insulation or air sealing allows house heat to warm the upper roof areas, and then the snow melts on roof surfaces and flows down as water. When this water reaches the cold eaves, with no heated space below it, it refreezes, and then the ice builds up, creating a dam that blocks the water flow. Water backs up behind the ice dam and leaks under the shingles. The solution requires proper insulation and air sealing and adequate ventilation, working together as a team to maintain uniform roof surface temperature. In hot, humid conditions, roof ventilation can actually add moisture to attics rather than remove it. However, not ventilating may void roofing manufacturer warranties and decrease the material life expectancy due to these excessive temperatures. This creates a dilemma that some builders and contractors solve with unvented attic designs, where the attic becomes conditioned space. Traditional vented attics remain cost-effective through imperfect solutions for most applications. Every attic needs ventilation openings, but it's equal to 1 divided by 150 of the attic floor area. So, for example, a 30-foot by 40-foot house with a 1,200 square foot attic floor area, you need 8 square feet of net free vent area. Calculate it. Measure the attic floor area, divide by 150. That's your required net free vent area in square feet. You can cut the required ventilation in half using the formula 1 divided by 300, but only if both conditions are met. You're in climate zone 6, 7, or 8 with class 1 or 2 vapor retarder on the warm side of the ceiling, and you have proper cross ventilation with 40 to 50% of the vents high up within 3 feet of the ridge and 50 to 60% low in the bottom third of the attic space. Don't be fooled by the gross vent opening sizes. A 24-inch by 24-inch gable vent looks like 576 square inches, but the actual net free area, accounting for louvers, screens, and frames, might only be 300 square inches, about half of the gross opening. Contractors have to always look for the manufacturer's specifications, showing net free area, not just vent dimensions. So during your inspections, verify both high and low vents for proper cross ventilation. In cold climates, using reduced ventilation, confirm vapor retarders are properly installed. And look for signs of inadequate ventilation like moisture staining, mold growth, or ice damage, rusty fasteners. Remember that ventilation effectiveness depends on proper intake and exhaust balance, not just total vent area. Roof ventilation works best when integrated with proper insulation and air sealing. Ventilation alone won't solve moisture problems caused by air leaks or inadequate insulation. The 3 systems must work together for effective moisture and energy control. Proper attic ventilation prevents ice dams, reduces cooling costs, extends roof life, and controls moisture, but it's not a standalone solution. It's part of a complete building envelope strategy that includes insulation, air sealing, and vapor control.